All right, this is page 198, and I want you to check out right up here at the top. We're going to do numbers 3 through 7. We may do 3 last because it's going to be the least helpful. So we'll do numbers 4 through 7 first. Those are all the problems that are similar to the test questions. And then we'll do number 3 last. And we're going to skip numbers 1 and 2 because they're not going to help us on this test so much. So let's check it out. All right, so let's start at number 4. We'll do 4 through 7, then we'll work back and do number 3 at the end. Rosa can run 4 miles in 56 minutes. How many miles does Rosa run if she runs for 42 minutes? This is kind of tricky unless you know what to do. So let's talk about this. So the information given to you is that she can run 56 minutes and she can do 4 miles. And then the question later asks, how many miles does she run if she runs for 42 minutes? And so if you set it up like this, there's no obvious next step. You're not sure what to do. You might try to look at 56 and 42. They're not compatible. You can't divide 42 evenly into 56. So you're not sure what to do. So I want to remind you that whenever you're not sure what to do, just check to see if you could simplify. It's called finding a unit rate. And you can. If you simplify these by 4, watch how easy this can be. You just have to recognize that that's the right strategy. 4 miles divided by 4 is 1 mile. And this term is called a unit rate. Now I need to find 56 divided by 4. That's 12 minutes. Actually, I think it's 16 minutes. I'd better check that. 56 divided by 4. It's 14. I told you 3 different answers. 4 goes into 5 once. 4 goes into 16 4 times. 4 times 4, 16 is 14. 14 minutes. All right, so now what do I do with that information? Well, you ask yourself, does 14 go into 42? Do you remember how we're trying to figure out 42 minutes? It does. If you multiply by 3, you would get 42 minutes. And the information we're trying to seek is, how many miles could she run? Well, 1 times 3 is 3 miles. In 42 minutes, she could run 3 miles. The answer is B. I would study this one super hard. Make sure you totally understand that strategy I just did, because that's a really important skill for this upcoming test. All right, let's check out the next one. Number 5. This is your chance to practice reading tables. Number 5 reads, the table below shows the number of petals and leaves for different numbers of flowers. And the question reads, how many petals are present when there are 12 leaves? If you look at the leaves, 2, 4, 6, 8, there's no 12. It's just not on there. But could any of those become 12 by multiplication? It really could. And I think the easiest way to check this out, I mean, you could extend the table, but I think the easiest way to do this would be to say, I noticed that if I took 6 leaves and multiplied it by 2, what would I get? I'd get 12, which is what we're looking for. And what you need to recognize is that whenever you multiply one term, you need to multiply the other term by the same number. So if you're going to multiply 6 by 2, you're going to multiply 15 by 2. If you were setting this up from scratch, you would do this. You would take this information and write a ratio as petals over leaves. And 15 petals is 6 leaves. That's straight out of our table. And we're trying to figure out 12 leaves, so that's going to be our second term. Notice we put leaves as our second term here. And then the math to get my unknown here is to go times 2. 6 times 2 is 12, so 15 times 2 is, it's going to be 30 petals. It's B. All right, again, make sure you understand that strategy. All right, number 6. A recipe calls for 3 cups of sugar and 9 cups of water. How many cups of water should be used with 2 cups of sugar? So I'm going to do 9 cups of water. Maybe I'll do it this way. I'll put my waters over my sugars. And that doesn't matter, by the way. You could set this up upside down. I'm going to do my waters over my sugars. I like to have my bigger term on top. 9 cups of water. So pay attention where I'm getting all these numbers. 9 cups of water. Put 9 as my first term because I decided water is my first term. And 3 cups of sugar. So 9 over 3. And I'm going to write that's equal to, I'm going to read carefully how many cups of water, that means I don't know how many cups of water which should be used with 2 cups of sugar. Now you might be stumped here because you can't divide 3 to make it 2. So what we do then is find the unit rate. We're going to simplify by 3. And if you divide both 9 and 3 by 3, you get 3 waters for every 1 sugar. And we're trying to figure out 2 sugars. See this right here? I'm just going to bring it down. We're trying to figure out 2 sugars. To get from 1 sugar to 2 sugars, you multiply by 2. So you multiply the first term by 2. 2 waters times 2 is 6. It's going to be 6 cups of water. All right, let's go check out the mini task number 7. And if we have time, which I think we will, we'll go back and do number, I think it was 3. All right. Number 7 reads, the unlabeled graph, and by unlabeled it means there's nothing. You're supposed to really have a description here and here, what we're looking at. The unlabeled graph shows the relationship between 2 customary units of measure. Only 2 pairs of units can be represented by the graph. Determine the possible pairs of units. Now you might think to yourself, I don't even know what this is asking. Well, I'm going to go back to my table here that we have. And the customary units of measure are all these things at the top. The bottom ones are called the metric. So I'm looking right here for things that could be on that table. Okay? So these are the relationships that could exist on that table. And in order to make sense of that, you have to look at the numbers. So here's some numbers I'm going to notice. This is 1. I don't know what, but it's 1. And it goes with 4. So my first point on here, this point right here is 1, 4. And 2 goes with 8. Now what do you notice about both those terms? Well, what you should notice is that the second number, 4, is 4 times greater than the first number. The second number, 8, is 4 times greater than the first number. So what does that tell you? It tells you that what we're going to look for on our customary units of measure is conversions that are 4 times greater. So here's what I mean by that. I could put this on the table, gallons and quarts, because there are 4 quarts for every 1 gallon. I could put this on the table because there are 4 cups for every quart. I can't put any of these other terms on there. I can't put, here's a wrong answer. I can't put this one on there because it doesn't show that there's 4 inches in a foot. And I can't put this one on there because there's not 4 inches in a yard. Those don't make sense. But what does make sense is the 2 numbers, the 2 conversions that go between from 1 to 4. There's 1 quart is 4 cups, and 1 gallon is 4 quarts. So the possible pairs of units are cups and quarts, and the other one is quarts and gallons. And it's simply because the conversion is 4 to 1. And then B says describe the relationship for each pair. Well, the first relationship is 4 cups in 1 quart. And the second one is 4 quarts in 1 gallon. And I kind of want to go back and talk to you about how this would make sense. This could be I'm just going to pick one of them. I'm just going to pick gallons. If this were the gallons right here, then this would be the quarts. And 1 gallon would be 4 quarts. And 2 gallons would be 8 quarts. And 3 gallons would be, it's off the chart, but it would be 12 quarts. All right, we're going to do one more problem. Now, I'm just going to tell you that number 3 here, this is our last problem. Number 3 here is a multi-step, kind of hard problem. It's a review from Module 4. It's a really cool problem, but if you want to opt out of this problem, that would be fine. We're going to let this problem be optional because it is not necessarily a good review. It's a good review, like for your broad learning, but it's not a good review for this test. There's no questions like this on your test, but I want to do it anyway, just for fun. If you want to join me, that'd be great. It's a multi-step problem. Number 3 reads, Megan is making bracelets to sell to earn money for the local animal shelter. It takes her 1/4 of an hour to pick out all the beads and 1/10 an hour to string them. So while it doesn't say this exactly, it does tell you that it takes her 1/4 of an hour plus 1/10 of an hour to make a bracelet. So that's one thing you're going to have to do. And then later it says this week she only has 5 1/4 hours to make bracelets. How many bracelets will Megan be able to make? So later on, after I get the answer to this, I'm going to then divide it. I'm going to divide 5 1/4 by this answer. So this is how long it's going to take her to make a bracelet. So the first review is that you can't add fractions unless they have a common denominator. And I'm going to go through my 4s and my 10s, and the LCM of 4 and 10 is 20, which means that makes this the common denominator. And to get from 10 to 20, you multiply by 2. And whatever you do to a denominator, you do to the numerator, so it's 2/20. And to get from 5 to 20, or 4 to 20, you multiply by 5. So my numerator will be 5/20. And so you're going to add those up, and you get 7/20. It takes her 7/20 of an hour to make a bracelet for each bracelet. Now, she has 5 1/4 hours to make bracelets, which is a lot of bracelets. But exactly how many we don't know until we divide. So we're going to do 5 1/4 divided by 7/20. And this looks hard, but watch how easy this really can be. First of all, remember that to divide fractions, you need to make this into an improper fraction first. 5 times 4 is 20, plus 1 is 21, so it's 21/4. And instead of dividing, I'm going to multiply by the reciprocal. So I'm going to invert this and make it 27ths. And now I have a lot of things I can simplify. I can simplify my 4 and my 20 by 4. 4 divided by 4 is 1, and 20 divided by 4 is 5. And I can simplify 21 and 7 by 7. 7 divided by 7 is 1, and 21 divided by 7 is 3. Now I have 3 times 5 is 15, over 1 times 1 is 1. 15 over 1 is 15, and that is one of my choices. It's C, 15 bracelets. Okay, great job. You are done with page 198, and I think you are probably ready for the Module 7 test. Good luck.